Wade here to talk a little bit about keys, primary keys and foreign keys, and some other key related terms at the beginning of week 4. So last time in week 3 we saw an entity relationship diagram for the parts database, and that included 3 entities: the supplier, the part, and the quantity. And the quantity was really an event, the shipment of a quantity of parts from the supplier to us. And each entity had a primary key called SID, PID, or QID. And the quantity entity also had 2 foreign keys, SID and PID. And the process of entity relationship diagramming allows us to identify the objects and events and processes that will constitute tables, usually 1 table per entity. And the primary key uniquely identifies a row in a table, making that row different from every other row in the table or relation. So I think I mentioned very early in the course that the relational model requires that every row be unique, but that software typically does not. So the way that we instantiate um, the uniqueness of rows in software is by having a primary key. Once we have a primary key, every row is guaranteed to be unique. Foreign keys are valuable in connecting one table to another table, uniquely identifying a row in another table or relation. And there's a process for identifying or creating a primary key. Usually you create it, but sometimes you identify it. So a domain is all the possible values for a particular type of attribute, but it can be used for more than one attribute. So for example, a person's name is a domain that can be used for employee name or customer name. A superkey is a set of 1 or more attributes that, when taken collectively, allows us to uniquely identify an entity or relation. So a superkey is a superset of a primary key. And a candidate key is any superkey that cannot be reduced to another superkey. So if you think back to the flights table, we had a primary key that consisted of the information about the exact time of a flight and its flight number. We could also add other things. That's the primary key, and that's also a candidate key. We could add the other things in the row to that, in the column, the other columns to that, and the various combinations of those would be superkeys. A primary key is chosen arbitrarily from the available candidate keys as the identifier for a tuple in the relation known as a row in the table. So if we have more than one candidate key that cannot be reduced to another superkey by subtracting columns from it, that candidate key can be the primary key. And if there's more than one of those candidate keys, any one of them can be the primary key. Anything that's unique is a superkey. So the whole row is typically unique, and some subset of the row may be unique. So let's suppose we have a list of people assigned to office numbers, rooms 101 to 109. And some of the people have identical names, but only one person is assigned to each office. And each office has exactly one phone in it with one phone number. And the office relation has any combination of these attributes that includes phone number or office number or both as a superkey. There are only 2 candidate keys, though, office number alone and phone number alone, because any other superkey can be reduced to one of these and still uniquely identify a row satisfying the superkey property. And either candidate may be chosen as the primary key. So here we have real data that can be identified as the primary key instead of creating it. And if you're very literate person, you may have read the novel 1984 and know the significance of Room 101 and Smith and O'Brien and Julia. But that's beside the point in this class. In any event, every row here is unique, but also every office number is unique and every phone is unique. So we can identify either the office number or the phone as the primary key But are these durable choices? Problems exist with using numbers or text found in nature as a primary key. Things change. For example, phone numbers can change, or a second phone is added to a room, or sometimes people shuffle offices or double up in an office. It usually makes more sense to make up a primary key. And in fact, it is quite easy in most DBMS packages to auto-increment an integer as the primary key each time a row is added to a table. And this is the case in SQLite as in most other databases. Sometimes, though, we create a concatenated key, also known as a composite key, consisting of several columns together, like in the flights database. And this is especially true in the case of associative entities like the quantity entity in the parts database. Entities that link to other entities, also known as intersection entities or intersecting entities or junction entities. Okay, now we should also know about functional dependencies. In any relation R, a set of attributes B is functionally dependent on another set of attributes A if at each instant of time each A value is associated with one B value. And such a functional dependence is written A um, determines B. That's how we would read this. A determines B. The left-hand side is called the determinant. So in the above relation, A is room 101 and B is Winston Smith. And there's only one occupant per room, so knowing the room number determines the occupant. So room 101 determines Winston Smith. A functional dependency is considered trivial if the left-hand side is a superset of the right-hand side. If so, it has the form AB determines B. In other words, if A does not determine B, we could still say that A and B together determine B, but it would be trivial to say so. Think back to the flights table. So we had a primary key in the airports table called FAA, which is a three-letter code for an airport. For example, Austin's FAA code is AUS. And the flights table contained two columns with airport codes, origin and destination. Each of these is a foreign key when it appears in the flights table. It can be used, for example, to get the full name of an airport to replace the three-letter code in a message. The foreign key is usually denoted in italics or oblique type, and if these are not available, a substitute is to write FK after the name. And I should also mention that a substitute, you know, primary keys are usually underlined, but if that's not available, writing PK in parentheses after the name is an alternative. Okay, so that's all I want to say about primary keys and foreign keys. Um, Thank you for watching.